Hey, welcome back to Common Sense OT Security. Today we'll talk about context and to be more specific about network context. So I'm just singling out one context dimension here to explain how important context is for your OT asset inventory. In very simple terms, you could say the difference between data and context is that the context for any data, sometimes also called the metadata, turns this data into knowledge that you can use to promote various use cases. You cannot do that with data, with isolated data alone. And I'm going to make my argument by referring to the network context. And what I'm showing you here, is the device inventory in OT-base, where you see basically one entry per device. And certainly in that device inventory, you also see the network address being exposed. So in the example that I've highlighted here, so this is a Rockwell 2198. That's a kinetics inverter, and we can see right away that it uses the network address 10.2.84.5, and that's all great. And however, it's not good enough. So just by knowing the IP address, you don't know anything about the network. You don't know what else is on that network and the characteristics of that network and so forth. And this is where the network context comes in. Maybe the one thing that you would know right away, that is the Purdue level of that network, of that device. Right? So for those who love the Purdue reference architecture, I don't need OT-base to tell me, well, this is Purdue level 0, because guess what? It's an actuator. So, and every actuator, by definition, is on Purdue level 0. So this has nothing to do with the network architecture, the topology. This is just the nature of this overstressed model. So I could simply drill down here into that device, get additional information about the networking. You would see, as I have just pointed out, the Purdue level is 0. Then you can also assign a zone. By default, it's set to the Purdue level by OT-base, but you could also use something like manufacturing zone or whatever you want to call that. And here it gets more interesting, because in this section of the device profile, we expose the connectivity of this particular device, including the network neighborhood diagram, which is created automatically. And this already gets so much more interesting, because now we can see the hardwired connectivity. We can see it's connected to these other two actuators. Why do I know that these are actuators without even bringing up the tooltip? Well, the color code tells me, because this is what we use by default for actuators. However, we also see the identity of the network exposed here in this table. So this is the body in white real-time 84 network. And obviously that is something that an engineer has slapped onto that network. By default, you would see the network address for that network. And we'll get back to that in a second. If you want to make it user-friendly, then you would assign something that makes more sense to the casual user. And the same thing with that color code with the network type. You will see that in a second. But the important thing is, this is already a lot of contextual information, because I see the direct neighborhood. I see the identity that this network, that this device is sitting on. Certainly, it could be sitting on multiple networks. But in this very simple case, where you're just looking at a kinetics inverter, it's only attached to one network, but it is connected to 2 additional devices. we see the physical information, or it's copper as a medium, 100 megabits per second. And now we're going to go one step deeper. And we can do that by simply clicking on this network name, which exposes the network identity. So we are going to drill down. And this is going to give us the network profile, which now tells us everything about that particular network. So we are no longer talking about looking at the individual device. We are looking at that particular network. We see it belongs to a particular network group. Certainly, this is assigned by the engineer as well. And in OTBAS, you can just define as many network groups as you want. You can assign color codes to those network groups. And then again, it makes everything much more user-friendly. I would get an idea right away about the characteristics of that network. And certainly, this is one thing that is important for designing or understanding OT networks, the difference between real-time and non-real-time. There are real-time networks in OT, and this has basically, at first hand, it has nothing to do with security characteristics. It is also, guess what, not reflected in the Purview model. Right. So, and just to give you an idea, those particular characteristics of the medium, they could go as far as if you think about Profinet IRT as an example. So the isochronous Profinet version, you're going to need specific switches, specific network switches in order to build those networks. So if only for that reason, it makes a lot of sense to use this type of labeling and metadata characterization. And then here we see the address space for this logical network. And again, this adds a lot of valuable information, because, I mean, just approach this from a security angle now, because obviously we want to know what else is in this very same subnet. Let me give you an example of why that is important. When you think about vulnerability management, there are certain vulnerabilities that can only be exploited if the malicious code is residing in the same subnet. Then there are other vulnerabilities that can also be exploited using routing. So you want to know what else is on that same logical network. And this is just one mouse click away in OTBAS. You see all those other actuators here, all those other drives. A very typical layout of a real-time network in OT. We see 2 PLCs exposed here. We see all their IP addresses, etc. So that's all good. And then our engineer was also kind enough to expose where exactly this particular network could be found in our facility. Okay, so now let's take it a step further. What I want to show you now is the networks inventory in OTBAS. And I think it's very important to understand this. So here you see a list where every single row represents one logical network. So this is no longer about devices, this is about networks. And if you cannot identify those networks and expose them in such a list, you're pretty much lost in OT and OT security for that matter. Well, because you're usually facing hundreds, if not thousands, of individual local private networks. And if you cannot tell the difference, you will be lost. So it doesn't make a lot of sense to only look at devices, OT devices at an atomic level. Being able to understand all those different networks with the different characteristics goes a long way. And you can see here that our users have made very proper use of those groups assignment. So you see there are switch management networks, there are these non-real-time IO, real-time IO networks, there is a SCADA network, there is even a safety network, okay? And that goes a long way. I could certainly also identify or inspect this particular network that we have been looking at just a minute ago by using this approach here from the network inventory, and I would get the same, the very same list that we have already looked at, okay? Now, the next thing that I would like to show you when it comes to network topology diagrams, which is an area that is particularly well addressed in OT-base. And here is one misconception that many people have. So many people think, oh, I've seen that before. I have seen it in the network, in the threat detection products, where you usually have seen these diagrams that pretty much look like flower beds from a distance. So let me show you what I mean by that. So here I'm referring to something from the good folks that where you. I think most people will have seen this. This is not a network diagram. This is a data flow diagram. Very important difference. So here you don't see network topology, you see data flow. And that data flow can and will often traverse multiple logical networks. So that data flow could even show you a connection to some device that is on the internet, okay? And that device is certainly not physically connected to your OT network, to your OT devices that you're looking at. So that's a very important difference. When we are talking about network topology in OT-base, we mean physical network topology. And let me quickly give you an example of how that looks like. I'm going to make it a little bit more interesting by selecting two logical networks, like so. In this table, I can select any number of networks that I like, and then ask OT-base to draw a consolidated topology map, because I'm interested to see the physical interconnections between those networks. In order to do that, now I just need to click on topology, and OT-base is going to draw me that joint topology, and you could rightly say, well, that doesn't look cool enough, right? So that looks meager. Certainly one thing that is already interesting here, OT-base knows, oh, these are all those connections between the switches. They are different from those which connect endpoints, and so therefore they're highlighted in blue, whereas anything else that is connecting an endpoint is in black. However, we can change that rather quickly to various different views. And what I would like to show you is when we look at the networks layout, because now OT-base will overlay the logical networks on the physical topology. So again, what you see here, those lines, that's the physics, right? So that is copper, a copper wire. And overlaid here, you have the logical networks. In this case, I see a couple of device level rings and how they are interconnected. And I can clearly see the outgoing conduits, if you will. And then down here, we have that other network, the non-real-time network that I've selected. And so again, this is another context dimension, and this is an important feature in OT-base. So in OT-base, when we talk about contextualized OT asset inventory, we're talking about multiple dimensions of context. So here we have overlaid the logical network architecture on the physical network topology. And we can do that in a number of ways. And the next thing that I'm going to show you is a little bit more complex again. So you can also start with locations. Let's just assume you want to see the network topology map for a whole building or for a whole site. And then you can do that by simply selecting the site, clicking on topology, and what you're going to get looks like this, where now we're looking at the physical topology, but overlaid is now the various geolocations, right? So we have our body in white building here with various different units. Okay, you could think about floor markings as an example. Then we have a server room, another server room within the electrical workshop. So this is just another way to represent multi-dimensional context. As you would probably guess, those colors, you can choose whatever you want. So we have just slapped green as a color code for anything related to server rooms on here. And the other thing that you can see here is that this is hierarchical. So those server rooms are within the electrical workshop, as it is clearly shown here, and everything is within that flat rock facility. So it's it can get quite complex, but it's still always super intuitive to understand, right? And then if you want to figure out the various connections, you only need to hover over any of those links, and then it's going to highlight what's going on. Now the last example that I want to show you is we do that similar consolidated topology map, but now at this time we're focusing on functional connections. What is the difference? In rather simple terms, so geolocation always refers to something that you can pinpoint on a map. With functional connections, that's not necessarily the case, because if you imagine, before I go into detail, so this is basically ISA 95. And in ISA 95, you're talking about process units, so things like work cells, machine lines, etc. And while those work cells usually have a dedicated geolocation, it sometimes can overlap, and for that reason it's modeled in OT-based as a separate dimension. So what do I mean by that? Let's just assume in a particular machine line, you have OT devices that are part of the machine line from a functional perspective, but they are not in line. There are not. If you go to the machine, you will not find those devices, because they might be in a server room that's on a different floor of that building, as an example, right? And for that reason, the systems view in OT-based is different from the locations view. And what I want to show you here, that you can certainly also do an overlay of that functional metadata level on top of the physical network topology. So here you could basically see the wiring that connects the various functional units. And again, that is of arbitrary complexity. You can go into the work cells if you want to. You can go to a station level if you want to. So as granular as you want. And that is just a little bit different from the locations perspective, because here in that functional view, I don't have, for example, the server room. I don't have that electrical workshop, because this is something that you would usually not find in an ISA 95 scenario. So that's basically what I wanted to show you today, and to give you an understanding how very much further you can go with those additional contextual data bits, if you want. So we are extending the raw data, like an IP address, to everything that surrounds this IP address and this network, okay? Because the IP address is on a logical network. That logical network needs a physical infrastructure to support it, right? And then you want to see what else is in that infrastructure, logical, physical, how everything is connected. You want to see where would I find those devices, where would I find those cables, and how does it all relate to the physical functionality when you think about ISA 95. And just to make that very clear, if you don't go down that rabbit hole, let me bring that up again. If you don't go down that ISA 95 rabbit hole that I've shown you here, with all those various functional entities, you will have a very, very hard time doing your network segregation properly. Because what you want to accomplish with your network segregation is that where it makes sense, those individual units, work cells, or think about machine lines, can continue to operate, they can continue to function even if other functional units have been compromised, have been taken down. So this is the whole purpose of network segregation. And if you don't have this type of visibility, you will be lost. Or worst case, you will come up with some totally counterproductive solutions, like using the Purdue model, right? You put all the actuators in one zone and then put the firewalls in there. That is total nonsense, my friends. Don't do that. Don't be that guy who simply fucks up the whole security of that site. And certainly, whatever you do in network segregation, it's very difficult to then do it right, to change it later on. So I hope this was helpful. Network context, super important, not just for OT security, but for a real understanding of what is going on in your OT environment. In OT-based, that even includes the field buses such as Circus, DeviceNet, ControlNet, Profinet, Profibus, and you're going to get a lot of information that you have never dreamed about. Talk to you next week. Bye-bye.